All right, good morning. This is it. Review for the final exam. Last time you're going to see one of these from me this year. Now, yours is going to look a little different. Let me tell you a couple things here right off the top. The questions I'm about to do are going to be like the same topics that you're going to have in this order. My questions are going to be different. Your questions are going to be different. The person, in my fourth block is going to be different from you because they're going to randomly throw them at you during the review. So I'll be same types of questions, but you may be like, I didn't see that question, right? Unless it's happen chance we get the same question, they won't be the same. However, when you get to the final, it'll be one of each type. Well, you'll see. So just wanted to give you a heads up on that. Also, thank you for watching this because you're going to see all the little detail stuff that other people are going to miss and then complain to me about later. So good job. Okay, so let's get down to this. You'll be able to just go in a row. I've got to do it this way. So here we go. So adding and subtracting polynomials. Now here, we know what we're doing, okay? I mean, we find the like terms. There's only one x squared term. You're like, yeah, Hardy. Now, when you're doing your squareds, you got a couple of options. You can either go to this button and use, this squared, or you always can use Shift and 6 to make that caret that we normally would do. That's another option that you have. So caret 6, or just using this. Make sure the negative distributes, so that changes the signs. 9 plus 6 is 15, so plus 15x. And again, that negative gets to the 4, minus 4, bam, bam, and we're off and running, okay? I'm only going to do a problem within each because I want you to have to think through. So again, you're like, okay, adding, subtracting, no big deal. Okay, multiplying. Now this one I want to physically show you. So here, if you wanted to just distribute and do, x to this, and then to this, and then to this, and then -3, this, you can. I am more of a fan, again, of being able to see everything I'm doing. So in an instance like this, my plan would be to say, okay, I'm going to add exponents. I multiply coefficients if they're there. So add my exponents. Okay. Here, -3 times 2 is -6. So I use my different rules for the different pieces. Then I can go back and start putting in my answer. So here I've got 2x. I'm going to use Shift 6. It goes up there for me. 2x to the third. Okay. My next pair, again, once the box is filled, I'm just combining like terms. So -6 and -5 is -11x Shift 6 squared. 15 minus 5 is 10 plus 10. Oops. Plus 10x. That's one of the other things with delta math that I've had people say, oh, I just got typing so fast. Before you hit submit answer, double check and make sure you're actually writing what you mean. Plus 15, like there, I had to put an equals in, and delta math's not going to take that. All right, I think I'm good. I am. Okay. So multiplying. Solving by factoring. Oh, dear. Now, there's lots of things that could happen with solving by factoring. Okay, biggest thing when you're dealing with factoring at all. If you have an x squared term, which you will, it's going to be a quadratic, everything needs to be on your x squared side before you start. So here, my first job is to get this 6x over to the x squared side. Now, something strange at first you're going to think is happening because 6 and -6 cancel. But is it really that strange? Not really. Because if you have your factoring help sheet, you're like, oh my gosh, all those help sheets, Hardy. Yeah, it would be worth your while to print those or jot those down on a piece of paper because you'd look at that and you'd say, wait a minute, two terms. Ooh, is that a difference of squares? Write it out, because again, when you're doing the test, you get plenty of time per question to be able to do it this way. First plus second, first minus second. But is it just asking me to factor? No, it's asking me to solve. Once I get to here, don't put that as your answer. Set each of those equal to 0. So how do I put that in as an answer? I should Now let's see, and this is the reason why it's good that you're going through this review, because you're gonna know this stuff going into the test, and you're not gonna be missing questions and then writing to me saying, you know, I didn't know how to do this. -2, 2. It puts it into set notation, which is how we normally would write an answer. So this should work. Now, will it work if you put x equals? I don't know. I'm just trying it this way. So let's see. Okay, it worked. Okay, would I have been able to write x equals 2, x equals -2? The world will never know. Right? Sum and difference of cubes. Again, you have a factoring help sheet that gives you all of these. Otherwise, I'll give you the form here too. You can jot it down if you'd like to. When we're dealing with sum or difference of cubes, if it's a sum of cubes, we'll use the plus first, and then the minus will come in here. Okay, that's sum. That's if there's plus in the middle. This one doesn't have plus in the middle. You're like, Hardy, why'd you show us this? Because you got to see both. The difference, if you have a difference of cubes, is that these two signs change. Okay, these will always be opposites. If I start with minus, the next one's plus. If I start with plus, the next one's minus. But for our problem that we're doing here in this instance, that's what we're going to do. And so I need to know, what do I cube to get each part? Again, if you have the factoring help, you have a list. If you don't, a quick, easy way to be able to get that number, and I'm going to zoom a little bit here. The quick, easy way to get that number is just to start messing with things. You're like, okay, I don't know, 2 cubed, no, 3 cubed. Okay, there's 27, 4 cubed. Okay, so I do this sort of like I do the other one. I'm like, if I've got 27 minus 64w cubed, what do I cube? What do I take to the third power to get each one? And then I'm going to follow the form again, and the form is following this. So we've got 3 minus 4w to the third, because again, this is A, this is B. And again, if you've got the forms, you're just copying, okay? You're not even having to do anything fancy. A squared plus A times B plus B squared. Follow the form, okay? So let's see. 3 minus 4w. Oh, Hardy. You don't cube w cubed to get w cubed. Hey, at least I figured this out a little bit sooner. Again, that's why I do these live, because I wanted to go through some of the same things you would go through. So, okay, error made, fixed. 3 squared is 9. 3 times 4w is 12w. And this squared goes to the 4 and the w here. So 4 squared is 16w squared. Nice thing about sum or difference of cubes, you never have to worry about, is there another step? Is there another step? It's just put it in the form, and I'm done. So let's see here. So I got 3 minus 4w close 9 plus, and again, you can use the keyboard they have here. I just am so used to using it on the actual keys that it just is a way I typically do it. But I will again show some ways we can do this. Let me get this back up. If it's just squared, I can even use the squared button here. Okay, that looks good. Yep, parentheses are in. Yeah, I think we're good. Yep, we're good. All right, good deal. All right, next one. Let me move these out of the way here. We'll keep a clean sheet ready. Graph the inverse of the graph provided on the accompanying set of axes. You must plot at least 5 points. Like, holy moly. Best way to do this, by far. Don't try to just do it on the sheet. So you start looking, and you're like, okay, where are some points that I can see that are on here? I can see 0, 2, and they can be random. They don't have to be in any particular order. But if you see spots, -8, 0. And again, what am I looking for? I'm looking for spots that are going through the crosshairs. So let's see here. -5, -3. Now if I go straight up from that, -5, 1. Oh, where's one more? Oh, there's one more. -4. No. 0, -4, because I went down 4, didn't go left 4. So you're like, okay, why did you do that? Once I find those 5 points, and again, you could start just from the vertex of the parabola and do 5, but it doesn't matter where. We're going to plot the inverses of all of these. We're just going to swap x and y. That's what the definition of an inverse is anyway. And so those are the points I'm going to look for. So let's see here. 2, 0, 0, -8, -3, -5, 1, -5, -4, 0. Okay. It'll make the parabola for me. And so let's see if we did it right. And we did. And again, you don't have to do as many points, but you see they did what we did. We took points and we just flipped them all. And so they chose to just do the ones starting the parabola and working it up. But as you can see, we took random ones that we saw and it worked the same way. So we're just clicking on, and what I did on each of those, of course you couldn't see because you're not sitting here with me, is you just go to the point and you click, and that's plotting the points. And if you don't like something you do, you just click the point again and you can get that. So again, nothing too bad. Okay, division. Oh, division. Some of you loved the division back when we were doing it. All right. So what's the result when this is divided by x plus 7? Okay, first thing. When we're doing synthetic division, we're doing it with none of the variables. So here, when I've got, I'm just going to write it out here so you can see what I'm up to. Okay, first things first. If it says x plus or minus, that's like you're solving it for x. In other words, you're going to switch the sign. But if I was solving that, x plus 7 equals 0, I'd minus the 7. So minus 7 is what I'm going to put in the box. If it just says divided by f of 3 or something, okay? If it looked something like this, then you would just use the value that's in the parentheses. So you've got to be able to tell the difference between these, because you may get either one. I can't tell you. So here, -7, and then just copy your coefficients, making sure that you don't have any degree gaps. 3, 2, 1, 0. Okay, they go all the way down to my constant. If I'd have been missing one, like let's say there'd have been nothing here, it would have been x cubed down to x, you'd have to put a 0 in that slot. Might happen, just saying. So 20, -11, -28. So synthetic division, we bring the first term down, take that number, multiply by what's in the box, that goes in the next slot, add down, take that number, multiply by what's in the box, put it in the next slot, add down. And if this is one of the places where you struggle, write the problem out with me like you are now. Make a little note on your paper, hey, this is synthetic division. And when you get to a problem on your test or your review where it says synthetic division, use this. You're building in your study tools as you go. Take advantage. Negative times negative is positive. That's 0. Okay, and so now I go back and I put my variables back in, reminding myself that whatever degree I started with, I start one below that. So I start with x squared, and then x, or x to the first, and then my constant. And if there would have been a value here, if, I would have put that over my constant. But since it's 0, I don't have to do that. So I come back over here and I'm like, all right, 3x, I'll use the thing this time, 3x squared minus 1x. Do you have to put in the 1? No, but it's not going to hurt. Minus 4. And again, there's the work through. I put 1, they didn't matter. We're all good. Synthetic division defines zeros. Oh, okay. So now, same idea, except this time, a couple of good things are coming from this. The situation I talked about in the last problem is happening here. So that's good for us. When we see f of 6 equals 0, that just means x equals 6. That's the number I'm going to put in the box. So when I go to factor this, so 6 goes in the little box. Let's see, I got 3, 2, 1, 0. I don't have any gaps, so I can just write my coefficients here. And I'm doing the exact same thing I did in the last problem. The difference is going to be what I'm doing at the end to put in my answer. So bring down my first term, multiply by what's in the box. Add down. Multiply by what's in the box. Add down. Multiply by what's in the box. Add down. Okay. I started with a cubic again. I started with x to the third. So I go x squared, x constant. But that's not the answer being asked for here. Don't type that in. It said find all of the zeros. In other words, solve this. Solve x squared plus 4x minus 5 equals 0. You can use the quadratic formula. You can use factoring. Do I even have to say which one I'm going to use? I didn't think so. Multiplies to a negative of each. Adds to a positive means the positive is going to be our bigger of the two numbers. Multiplies to 5, 4 apart. Okay, got this. Set those each equal to 0. Now here's the part that's interesting, okay? Those aren't my only two answers, okay? Being told that this is a cubic tells me there's 3 answers. You're like, where am I supposed to get the third one? I've already got this. You have the third one. They gave it to you. Those are my 3 answers. You've got to get them all, because if you only put the 2 you solved for, it's going to tell you it's wrong. So we've got 6, comma, okay, comma will get you split up into different numbers here. Negative 5, comma, 1. Set notation. Submit answer. Okay, so I got to remember, they're actually giving me one of the answers. So it'll be interesting when we go to see if people pay attention to that. Okay, end behavior. Oh dear. End behavior. Okay. Again, I'm going to draw a quick sketch of this. I'm not going to get too fancy with it because I just need something to be able to reference here. Okay, so x-axis, y-axis. Reminder back when we did end behavior. We talked about how when we go to the right, forever to the right is positive infinity, forever to the left is negative. Okay, when we look at y, up is positive infinity, down is negative infinity. So what are we being asked for? What direction is the graph going? Okay, so let's scroll down here. We got choices. First thing we need to keep in mind, x is always going to be 1 positive, 1 negative, because that's how this works. We're looking from left to right. So if you look at all the answers, all of them have x to the negative infinity and x to the positive infinity. So that's not where the difference is. The difference is what's happening to y. So here's what we're going to do. Look at the left side of the arrow. The left side of the arrow goes with my negative infinity. What direction is that heading as far as y is concerned? Up. Okay? So when x approaches negative infinity, y approaches positive infinity. That's one part I know. Then I do that with my arrow on the right, which corresponds with positive infinity. What way is it going? Up. Okay. Which infinity is up with y? Positive. So what am I looking for? I'm looking for the one that has f of x, a fancy way of saying y equals, that has positive infinity for both. Positive, negative infinity. Nope. Negative infinity. Nope. Positive infinity, positive infinity. Negative, positive, positive, positive. That's what I got. It's this one. I would draw it out so I can circle and I can start making references, but you do you. Okay, growth and decay, growth and decay. All right. So when we do growth and decay, given the following function, identify whether it's growth or decay and determine the percentage rate of increase or decrease. Okay, so here's the other deal, and I'll make reference to this. I'm not going to do it right now, but I'll make reference. You are still going to have access to the help videos and questions, okay? So just something to keep in mind. When we're looking at growth or decay, okay, that is going to be my rate or my percentage increase or decrease, all based off of 100% or 1. So here's the general rule here. If this value is less than 1, it's going to be a decay. It's going to be a decrease because anything less than 1 is going down in value. Okay? We talked about this before. We used fractions most of the time, but here we're using decimals. It's the same thing. If this value is greater than 1, that is an increase or growth. So to answer the first question they have, is this growth or decay? It's growth. It's greater than 1. If it was something less, like 0 point something, that's decay. Okay? So this one is growth. We'll leave it. What's the percentage of increase? So here's how you figure that out. This is always based off of 1. Okay? So 1.01 minus 1, because that's what our base would be, is 0.01. But that's not the question. What percent increase is it? Multiply that by 100, turn it into a percentage. That's going to be a 1% increase. Now, we're actually going to do a second one of these in a minute, so I'll leave that at that for a second. I want to do a decay. Okay, so we got it. Now let's do another one of these. Okay, perfect. So I get another one, and now I look, and I'm like, okay, Hardy, I got this. It's less than 1, so it's decay. Okay, to figure out what, it's 0.42. So 1 minus 0.42, because I always put the bigger number first, is 0.58. But again, don't put the 0.58. Percentage. Multiply it by 100. Move it 2 decimal places to the right. 58% decrease. Okay, so it's always based on 1. If it's less than 1, we'll subtract it. If it's greater than 1, we'll take the number minus 1. But that's always how growth and decay works, okay, and kind of figuring that out. All right, still rolling. Evaluate logs. Okay, oh dear. You're like, okay, Hardy, how am I supposed to do this? Okay, we're going to do a couple of these because this is going to get a little more interesting, I see. Here's one thing I'll tell you. When you're finding values on the final, I'm keeping it to regular logs, but I'll do a natural log here just so we can kind of play with it. I wouldn't do this one to you, though. When we turn, oh dear, this into its exponential form, okay? We're having to rewind. This wouldn't be an unfair question. I'm not going to say that. 3/4 exponent over index. Now think about that for a minute. Natural log and E. Natural log and E are inverses. I can just cross them out. So the answer is actually 3/4. But here's the cool thing. Could I do this on my calculator? And the answer is yes. I can hit natural log. And then remember, E is second in natural log. .75, math, enter, enter. Okay, 3/4. So again, you can get it either way. Now again, I'm not that cruel and unusual. Okay, this is much more likely what I'm going to give you. So remember, when you get a regular logarithm, okay, we can either look at it as, hey, 8 to what power is 64? If I know that off the top of my head, I'm good. If I don't, we can use change of base. Log big divided by log little. And I mean physically, the 8 is littler than the 64. Pop the calculator. Log 64. Oh dear. My calculator's going to die. That's not cool, but you know, it's 2. So go to submit answer. Yes. Hey, we're rolling. All right, I'm just peeking around because I'm seeing if I'm going to need a backup calculator. I'll figure that out as I go. If not, the brain may become my calculator here. We'll see. That's what happens when we go live with this stuff. So, all right. So, kind of gives me a couple different looks there. All right, condensing logarithms. Oh boy. All right. Back to our reminders again. When we're condensing, okay, because we'll have expanding coming here soon in a bit. When we're condensing, here's the order we're going to look at. Again, not a bad idea to have this stuff jotted down somewhere, just saying. All right. Coefficient to exponent will always be what I do first. And then second, and I'm going to do this from left to right just based on what I see, I'm going to have add is going to become multiply, and subtract is going to become add. So what's that mean for me on this one? Well, let's see, 3 log c minus y log d. All right, coefficient to exponent. Coefficient, yes, a variable can be a coefficient to exponent. Log c to the third minus log d to the y. Okay. Then I don't see any adding, so I don't have to do that this time. And I've got subtract. What did I just do? Really, Hardy? Again, live, you get me in for all I am. Subtract is divide. I was thinking too far ahead here. So I go, okay, the goal when we condense is to get down to, subtract is divide, 1 logarithm, 1. I don't care how many terms are there, we're getting to 1 log. So I look and I'm like, okay, they've already got log here. So C, I'll pull this back up. I need to use this button if I'm not going to use Shift 6 here, because this one lets me plug in any number I want up there. I don't want squared this time. And when you hit the divide button, whether it's on here or on your keyboard, it'll get you to this part. And then D to the Y. Yep, that looks like what I got. Bam. Okay. So again, the only other thing you could run into is if you had addition there instead of subtract, it would just be multiply. So no big thing. Okay. Expanding logarithms. Okay, I'm going to switch problems because I want you to have to do, can I get everything in one? Yes, I'm getting greedy. I want everything in one. You wish you had the opportunity to keep flipping these, don't you? I'm just going to roll with this one. Okay, so condense was there. Expand, we talked about before. It's just, everything's opposites. Okay, so my first thing, left to right, is going to be multiply becomes add. We're just inverting all of this. Divide becomes subtract. And then after that's all done, if I have any exponents, they're going to become coefficients. Nothing else is different. So I've got log x to the 5th times y to the 3rd. I like to actually put the little multiplication dot in there so I can remember. So I'm like, okay, that becomes add. Log x to the 5th plus log y to the 3rd. The idea of expansion is I'm getting more logarithms. So here I went from many logs to 1. Now I'm going from 1 log to many. No division this time, but I do have exponents. Those are going to become coefficients. So let's see here. 5 log x plus 3 log y. Damn. Rolling, people. All right, logarithmic form. Solve for a positive value of x. Okay, so here's what's going on this time. We need to get this into exponential form. Okay, now we did this before. We went from log to exponent to log. So when we were doing this before, okay, we always said when we were going from one to the other, it was base, exponent, answer. Logarithmic to exponential. Log, exponential, okay? So what do I have here? I've got log x 125 equals 3. Okay, so what does that mean as an exponential? Base, exponent, answer. X to the third power, what number, it's not asking you to just put it in exponential, it said solve. What number to the third power is 125? So if you don't know, you start playing on the calculator here. You're like, well, let's see, 3, no, it's not big enough. 4, that's not, oh, 5. So x equals 5, and that's all I want. That's all I want. Okay. So they're all looking that, now, again, let me flip one more time here. Okay, let's say it changes and it looks like this. Let's play with one more of these. Log 9x equals 2. Okay, the x moved this time. Does that change the way we write this? No. That's still my base. That's still my exponent. That's still my answer. What's 9 squared is what this is asking. X is 81. So the x can move around, but how you change the logarithm to an exponential doesn't. Still can get the answer easily that way. Okay? All right, solving exponential equations. We're still rolling. Oh dear. Solve for x, rounding the nearest hundredth. Okay. So now I look at it and I go, all right, so ex to the fourth equals 7. What's the opposite of e? Because that's my first job, is to get this alone. The opposite of e is natural log. And in algebra, whatever we do to one side, we do to both. So those cancel, x over 4. All right, natural log of 7 here, just a second. Natural log of 7. My calculator's back now. Okay, so like 1.95, we'll call it. Now this is gonna be interesting to see. Oh, solve to the nearest hundredth. Okay, so far we're there. And then what's my last step gonna be? Multiply by 4. This is gonna be interesting to see if, because I rounded, if I get this wrong. This is why we test these out. Okay, now, let's see for a minute, if I didn't round it first, if I kept this answer. So I'm gonna type that whole thing in here, 5910149 times 4. Okay, ooh, watch out, okay? If I would have rounded it first, since it's asked me to round to the nearest hundredth, if I'd have put 7.8, it would have told me I was wrong. Because the nearest hundredth is 7.78. Word of advice, do not round until the very end. Okay, so keep the big number in your calculator or on your paper, because if you go off and just do your own thing, you're gonna have a problem. So see, this has already been helpful. I've already saved you at least one question here. Okay, 7.8 ain't gonna get it done. And if you email me and go, look, my answer at 7.8, I'm gonna be like, no, it's said to the nearest hundredth. You've got to be careful. All right, let's see. Get one more in here. This review is going to go a little longer than I had originally planned, but that's okay. I want to make sure that you're putting in the time, so I want to make sure you're getting your value here. All right, first job, get the 44 out of there. 3x equals 1/4. If you put 0.25, it's not going to matter. How do I get rid of the 3? I hope you didn't say divide. Okay, this isn't 3x, it's 3 to the x power. The inverse of a value, the inverse of a base is its logarithm. And over here, remember, that's change of base. So what's change of base again? Log big. And in this case, that's the 1/4. I know it's not the bigger number, but it physically is the bigger number divided by log little. And again, nearest hundredth, negative 1.26. Negative 1.26. Bam. And we're going 100 for 100 so far. Woo! And we're way over halfway there. All right. Exponentials with a common base. Okay. Again, we looked at these before, and there were two types that we did. We did one where I could just take the smaller base and look at that and go, okay, can I turn 81 into 3 to some power? That's always what we're going to try. So we're like, okay, 3 to the third, 3 to the fourth. Ooh, I can. 3 to the fourth is 81. So 81 to the negative 1 becomes 3 to the fourth to the negative 1 equals 3 to the 2x. Our goal is to get those two to be the same. Once they are, exponent rules tell us we multiply the exponents. Now, what's actually happened here is that by logarithms, those are gone. So 4 times negative 1 is negative 4, because that's just an exponent rule. This is just 2x. Solve it. Divide by 2. Negative 2. Okay, I think I want to make sure. Oh, dear, that's big. Those are all going to do that. Okay. So every problem in that first part, they're all going to, one is going to get you to the other. Okay, that's good. That's good. All right, solving linears. Oh, hey, look, it's the stuff we've been doing recently. Whoop, whoop. Solve for x. Okay, so let's see here. 3x plus 8 over x minus 3x plus 3 over 2x equals 1. Do not be that person. Do not start canceling stuff. Remember, when we're doing this, we're going to do a couple of things to make sure that we don't do something silly. First one is, since we're solving, we're going to make sure that our extraneous values, that we don't get sucked in there. Okay, if I set x equal to 0, if I set 2x equal to 0, I get the same thing. X can't be 0. So that's my first thing. Second thing, my LCM. Just looking at those. 2 is my coefficient. X is my largest exponent. But again, you should have your help sheet somewhere handy if you need it anyway. Just saying. So here, I'm going to multiply through here by 2x. And so as I do that, on this first one, the x's cancel, but the 2 is still there. So I got 2 times 3x plus 8 minus, I get to this next term. The 2x's all cancel. So 3x plus 3, don't lose your parentheses. But now you get to the last one, you're like, well, wait a minute, nothing cancels. Like 1 doesn't cancel anything in 2x. Okay, so if I multiply across, 2x times 1 is 2x, divided by 1 is still 2x. The whole idea of multiplying by the LCM is to get rid of the fractions. And now I can do my other work. And now it's just, can I make sure I don't do something silly with my Algebra 1 skills? These are on the same side of the equals. Don't do opposites. These are on the same side of the equals. Don't do opposites. Solve for x. I'm going to go to this side because there's only x's over here. Not quite done. Is that my extraneous value? No, this actually works. Okay. Again, if you put in your due diligence, like I've said the last couple of weeks in practicing, you're going to be able to set that up and get that done well. So that shouldn't be a big problem. Okay, again, rational equations here. I'll pop another one out. Why not? Okay, the types that we got here. So we got 1 plus 9 over x minus 8. I'm going to put that over 1. Equals 2x over x minus 8. Same process I run through. Nothing different. What's my extraneous value? Set that equal to 0. X can't be 8. Okay? And that is my LCM because I don't have a coefficient. I don't have a single variable, and those are the same. You get to a point you should be able to just roll through these. I'll be honest. Even if it's just watching this review for the first time, it should get you thinking. And if you need extra practice problems, there's probably a Delta Math assignment you could go back on. Take note of the title. So like rational equations, you'll find it. Okay. So again, here nothing cancels. So I need the x minus 8 here. The x minus 8 cancels. Just take the 9. Here, the x minus 8 cancels. I get the 2x. Same side of the equals. And the reason I can do this is, I mean, technically there's a 1 here. I could distribute it. Normally I'd do distribute before I'd start combining things in parentheses. But since there's nothing in front, I can get away with it. Minus my x. X equals 1. Doesn't match my extraneous. I'm happy. I'm moving on. I'm rolling. Okay, that's similar to what we just did, so I'm not going to keep doing a bunch of those. Okay, simplify rationals. We got to be able to do a little factoring here. So let's see. X squared minus 1 over x cubed minus x squared. Okay, factoring can be lots of things. In this case, now in this problem it's not, but it could be a diamond. It could be slide and divide. It could be a difference of squares. First plus second, first minus second. Notice I put the parentheses around because I'm not going to be that person. You can't cancel those. Somebody's going to try. Not a good idea. It could be they just have something in common. Okay? Again, when you're factoring, it's the smaller exponent you will take out. I got 2 x's, I need 3. I need 1 more. Now be careful here. Well, I've got everything already. X squared times what gets me negative x squared? Minus 1. Once you've factored, now you can cancel stuff if it's identical. But be careful. You're going to think about it. If you don't put the parentheses, I'm telling you, you're going to try and reduce these. You can't do that. So here, x plus 1 divided by x squared. Now let me show you something when you're typing in answers, how this can screw you up even more if you don't use parentheses. I'm going to back up. If you do x plus 1 divided by x, oh, Hardy, that's not what I'm trying to write. Right, that's why you use the parentheses. This is why those of you that have done your Delta Math stuff as you go along, it's going to pay a dividend for you here because you're not going to get screwed up on that. Well, and hopefully if you've watched this now, you don't get screwed up on it either. All right, LCM. Oh, Hardy, what the heck? Why are you giving us 3 of them? We haven't, well, okay, we can do this. What's the least common multiple of 6, 8, and 9? Okay. Now, one way, I'm going to show you the long way first. Still isn't the worst thing ever. It's just going to take me a minute. So I start to list these out. Now, with 3 of them, I need to find the first number that's going to show up in all 3 lists. Now, as you'll notice here, nothing has shown up that's the same in all 3 yet. 24 is 2 out of 3, but that doesn't count. So as I keep rolling here, and I'm going to keep rolling here for a little bit, this won't take me much longer. You're like, Hardy, are you sure it's not going to take you much longer? Because you still aren't there. Oh, I'm just work with me here. For some of you here, it's a nice kind of brain break for you as I'm working my way through this, and some of you are chuckling going, does he even know what the answer is? Like, he might be writing off the paper. Oh, no, I'm not going to write off the paper. I made it. Okay. Now, if you're like, I don't want to do all that, remember, we have a calculator option. Okay. If you want to use the calculator to find your LCM, you hit Math, okay, right below the alpha key, right below the green key. Go over to numeric, and we're going to go down to number 8, LCM. Now, if you remember, we can only do 2 numbers at a time. So we're going to do 6 and 8 first. So 6, comma, the comma's right above the 7. So 6 comma 8, you get an answer. You still have the 9 to deal with, so we do it again. Math, numeric, LCM, the 24 that you just found, and the 9 that we still have to use. There's my 72, okay? Calculator does it, write it out. If you have a multiplication chart somewhere maybe that you've used, find 6, 8, and 9 and find a number that they all have in common. Any of them work, as long as we get to the magic number of 72. Now, may you get lucky and you only get 2 numbers to work with? Maybe. I ain't telling you though. Oh, we're almost there. Hallelujah. Multi-step inverses. Okay, inverses. I need more paper. All right, just a second here. Ugh. I told you that this final exam, it's chunky, but man, if you can show me you can do this, I feel happy giving you the extra grade or the passing grade. Okay, so f of x is really just y equals 8x plus 10. Okay, so first thing when we're finding an inverse, switch x and y. Okay, the second thing we're going to do is solve for y. Now, for me in this case, I think it's going to be easier if I distribute that 8 through first, because I don't like having y in parentheses. That could be a mess. So I get here, and now I'm solving for y. So I need to get the 80 out of there. Okay. And then I just need to divide by 8. Now remember what the problem we had a couple problems ago? Make sure anytime you have plus or minus in an answer with things that you're using parentheses, make sure your answer looks like, and you're like, Hardy, I don't see that answer in any of these. What did you do wrong this time? I didn't. Okay. There's a way I can simplify. Let me back up here for a minute. When I'm here, okay, one option I could have, and this again is showing your mathematical ability to flex with what's going on. You can always take a fraction and separate it into separate pieces. They have the same denominator. I'm just taking them in pieces. What's 80 divided by 8? Well, 80 divided by 8 is 10. Does that show up anywhere over here? Yes. Okay. Got to be able to adjust. Dang, Hardy. What the heck? Oh, hey. All right, let's see here. All right, so this time we got a fraction to deal with right away. All right, let's do this. So y equals x minus 7 over 7. Do not cancel the 7s. Y minus 7 over 7. And I start doing my algebra stuff. I'm like, okay, I got a fraction. I want to get rid of that. The opposite of divide is to multiply. Bam. 7x equals y minus 7. Add the 7 over. This one we shouldn't have an issue, and we don't. Okay? So again, switch x and y, solve for y. Big deal. Almost there. Oh my gosh. Graph this on the axes below. Okay, let's keep this simple. Grab your calculator. Okay? Y equals, type in exactly what you see, no matter what is there. X minus 2. Make sure you bring, in this case though, that you don't end up with your, zoom in a little bit here. Okay, make sure you don't end up with the minus 4 up in the exponent, because that wouldn't be right. So you're like, okay, so I graph it. Well, Hardy, how am I going to get the points and the asymptote and all that stuff in here? Well, a couple things. Okay, first things first, let me pull my chart. To get my points, just grab a couple of whole numbers off of here. So I see 2, negative 2, so 2, negative 2, and I see 3, 4. Okay, I still have to plot my asymptote though. So when we're doing growth and decay, that's what this is. There's no logarithm. Growth and decay, we have a horizontal asymptote. Okay, you're going to have to know that. If it's a logarithm, it's vertical. if you're not sure, again, look at the graph on here. Where does it seem to flatten out? It's flattening out going this way. Okay, if you do a logarithm, it flattens out going this way. That's what I'm basically looking for. So I don't have to, oh wait, I do need to do the asymptote. Because the asymptote ain't way down there. You're like, well, how do I know that? What value do you see keep repeating and repeating for y? -4, even though it's not really, it's really close. So I need my asymptote to be at -4. Just below. Now I look good. Okay. I'm going to play with a couple of these here. Let's see if I get a log this time. If I don't, I'm going to... let's flip. They're going to give me a log. Okay. So this time I get a log. So I'm like, all right. So now this gives me an interesting thing. I have it set up. Okay, I'll admit it. I have it set up on the final where it's either a base log. Okay. Actually, I want to do that because I wouldn't do that to you on the final. I might just stick with growth and decay because I'll be honest, I'm going to tell you in advance, it's the growth and decay problems that I put on the final. So let's just do another growth and decay here. Okay, so I type this one in. I can look at the graph first. Okay, so I get that in here. Pull up my chart. Now I got lots of whole number answers to play with this time. So let's see. So I got -1, -6. There's -1, -6. And I got 0, -3. Still going to be horizontal. So again, it's still growth and decay. But now this time I start looking. And you're like, well, they're kind of getting really close to 0. Because remember, E is 0. So if I look at the graph again, it's getting really close to 0. So let's drag this to 0. And notice how it went from opening up to opening this way. Same way mine is, okay? If you are doing yours and you happen to get a logarithm on your review question, don't worry about it, okay? Because on the final, it's either going to be a straight log, okay? If you get a log with a funky base, I'm going to show you that in a minute here. I do want to show you one thing. Hang on just a sec. Okay, expanding logarithms. Before we expand here, okay, I want to show you something. Because I've had a couple of you ask on some of the other reviews, hey, I needed to put a log in. How do you put the little base number in? Because if you come on here, there's a way to put in an exponent, but there's not a way to put in a base number. So just as a reference here, and I'm going to say this in class a couple times too, if you ever need a subscript, a little number is what's that called, you're going to hit Shift and the negative key on your keyboard if you need that little number sometime. Okay? Shift, negative, subscript. I'm going to mention that again today. So just something to be aware of. Okay, let me get the calculator out of the way. We don't need it anymore at this point. At least I don't think we do. So expand, we talked about expand earlier. Oh, help if I'm in the screen. Expand means we're going to have lots of logs. So let's see if we can remember this without now pulling up all the help sheet here. So when we're expanding, we've got divide becomes subtract. So log y to the 4th minus log x to the 5th times z. You're like, Hardy, why didn't you do the next part? Why didn't you go ahead and turn this into plus? Because I just like to do it one step at a time. That's me. If you can see all that at once, shoot, you do that. So log y to the 4th minus log x to the 5th plus log z. Now, there's one other thing I'm going to mention before we move ahead, because again, Delta Math can get a little touchy. Right now, if you were to do this and to smash it back together, okay, to condense it, Delta Math would think you wanted y to the 4th divided by x to the 5th and then times log z. Since these are together, I'm going to keep them together. I'm going to use the parentheses. It's one of those, I don't want to take a chance. And so then my last thing, since I have exponents that are going to become coefficients, no more coefficients, no more multiply, no more divide. That's my answer. So 4 log y minus 5 log x. Oh, Hardy, keep your parentheses. You know what? I'm going to test it. I'm going to not put parentheses in my answer and see what happens. But I still think we're going to need to do that. So let's test this out. I have a feeling it's going to tell me I'm wrong. Yeah. Why? Because, what did I do? Now that's interesting. Now see, now I wish I would have put the parentheses. If I'd have put the parentheses, I think it would have taken it because they distributed it. Because you're like, well, wait, their answer doesn't match yours. Oh, but it does. Because if I distribute the negative, I get negative 5 log and I get negative log z. I bet you it would have taken the parentheses. Dang it, I wish now I could go back and do this exact same one again. Well, so goes life. We get one more to do anyway. Oh, I'm going to get a second chance. Actually, I want to get it. Oh, no. Yep, that's what I want. You're like, wait a minute. Ooh, did I get the same problem back? Sweet. Okay, we're going to type it in differently. I want to try this. I'll still do another one with you here, just a sec. Okay, so 4 log z minus 5 log x plus log y. Okay, so my experiment here is, if I don't distribute the negative, if I just put the parentheses to say I still want this stuff together, okay, will it take my answer? Yes, it will. Okay, that was good. That's good to know. That's good to know. All right, let's see if we got one more here. Okay, let's do one last one. Oh, you have survived. I know. I just took a huge chunk of your life away, but I appreciate your willingness to do what you got to get a good grade here. Okay, rock and roll. Log x to the third plus log y squared, still together, minus log z to the fourth. And now it's all about the exponents becoming coefficients, people. 3 log x plus 2 log y minus 4 log z. All right. Keep your parentheses, Hardy. Even though this time, I think we'd have gotten away with not doing it, but I'm not taking a chance. Grade rolling here is too important for me to be worrying about one set of parentheses. Did I type that in right? Yes. Bang. Okay. Last word of advice for you on this, okay? Glad you watched through this. I would suggest if you found some places where you'd had issues, okay? Go through a review and just do those sections. You can bounce around sections on the review. It's not going to make any difference. It doesn't cause any harm. Bounce around some there. See what you can do. Shoot me an email if you need to, whatever. Make sure you're ready before you take the test, okay? Review, have your help sheets ready, have your examples out, be ready. With 90 minutes to do 30 questions, you have more than enough time to do what you need to do. But have your stuff prepared. I'm sure you're going to do terrific on this, okay? But before you start that, if you've got questions, let me know. Otherwise, it's been a pleasure. Good luck, and we'll see you at grade time.